Hi, this is János, Real Audio, and this is a video log of the original Quicksilver mono. Yes, if those of you who know about it, this is the original 8417 vacuum tube. So this was the very first Quicksilver mono, and the new ones with the 6550 or KT88 power tubes, those are the descendants of this amplifier. And so this one has been modified by Stu and me, and they include quite serious modifications to the original design. But let's go through what was in the original design and what were my changes, because what I'm going to do is that I'm going to change it over again. Because what Quicksilver, what Mike Sanders at Quicksilver did is that this power tube, the 8417, has a stability issue. Sometimes this tube the screen shorts, and that kills the output transformer. And this is what happened here. As you see, the output transformer is not there anymore because it blew. So I'm going to replace it again, because this is the second time that the output transformer in this unit has blown during the, I think, like 20 plus years of life of this amplifier. And what Mike did is that he got rid of this vacuum tube, which is a really nice sounding tube, but it has this problem that the grid spacing is too narrow inside the vacuum tube, so there can be a short, and that will kill your output transformer. And what he did is he replaced it with the 6550, and what I'm going to do is replace it with a vacuum tube that is a little bit more accessible, more cheaper. It's the 807, so it's a different pentode, the 807 pentode, and I'm going to run it in triode mode. So that's it. And because of that, I'm going to do a major rework. But before I do that rework, I want to show it and also document it for myself how it looked like originally. So as you can see, it has, when we look at the power supply section, so this is the power transformer. Quicksilver makes their own transformers, own power transformer, and behind this there's the output transformer right there. And that's why, that's one of the secrets of the Quicksilvers, is the in-house made absolutely excellent transformers. And so here, this is the power transformer. This is how it looks on the outside, really big boy. And that's here, it's feeding the two rectifiers. It's a pair of 5AR4s, and the pair of 5AR4s is feeding here an input capacitor. Input capacitor feeds the power stage, and it also feeds through a choke the input and the driver stage. So here's the input stage, driver stage. We'll have a look at that in a moment. But you see, that's the first filter capacitor, and that's the second filter capacitor. And looking at the other unit, this is how they look like. They are really, really big bad boys. 500 volt rated, 330 microfarad capacitance. So that's quite a lot. And as you know, if you have a vacuum tube rectifier, that's about 8 times bigger than a normal vacuum tube rectifier can handle. And that's why Mike did, Mike Sanders, he has 2 rectifiers in parallel. So now what we have is that the input capacitance is just 4 times higher than what the 5AR4 would like to see maximum. And however, what's happening here is that Mike is using US made 5AR4 rectifiers, and for them, like for example, you put in a pair of General Electric 5AR4s, or maybe you put in the Mallards, the British ones, and they don't give a care about that oversized input capacitor. Here, these rectifiers, those GEs, there are like 20 years old, and they've been fined for 20 years serving that absolute overload. Try to put in any modern made 5AR4s, you will have absolutely spectacular failure. Probably it will give you a light show within a month. They will not last in this amplifier a month. And when it goes, then you will see probably maybe even fireworks happening. So I absolutely urge everyone who has Quicksilvers, these original triodes, original monos, these are not triodes, just original Quicksilver monos, or even the newer ones which have that much input capacitance. Most of the Quicksilvers do. Never ever try modern made Russian or Chinese rectifiers with it, because they are going to fail you spectacularly on that business. And yeah, so that's how the power supply is. Plus what I wanted to see is that here, so this is here we go, we have the filament winding. So there's the filament for the rectifier, and then we have the high voltage as well. And let's see, or maybe the other way around. Yeah, I would have to check the pin out. And now through this camera I don't see much anyway. My eyes are not that good to see which is which, but I think these are the high voltages and that's the filament, but I might be wrong about that. And let's see. So what is happening here, we also have here that winding, that green one that goes out, that's the filament for your power tubes and driver tubes. And that voltage that's coming out, that 12.6 volts, so it's feeding these the output tubes in series. So it's like 6.3 volts on top of 6.3 volts, adding them up in series, that's 12.6 volts. And so that's why they are connected in series, they are not in parallel. And then the input tube and the driver tube are connected right here, like between the two tubes. So they have the 12.6 volt feeding here, and that's jumpered over to the driver tube. So that's how they are being fed. And what I did here is I added a bunch of resistors, so they are dropping the voltage to bring it down, because when they were made 20-30 years ago, the line voltage in the United States was lower than what it is today. And if you just quick in the old monos now, you will have more than 12.6 volts, like maybe like 14 volts or something like that. And it will work like that, but it will age your tubes very fast. So I don't recommend that. So that's why I recommend put in the voltage drop resistors, and they are really tiny. Look at that. These are 0.15 ohms times 3, so half an ohm resistance, but you need quite a bit of wattage because there's some current going there. And of course I overdid it, so it's much higher wattage rating than necessary, but it's good because it makes sure that these resistors run nice and cool and they don't burn anything there. What else? So here we have, these are the output tubes there, and originally here we had pots like this, but they were part of the fixed bias circuitry. And this was the winding from the power transformer that carries the supply for the fixed bias, and then it would have run there, and with those pots you can set the bias for the tubes. And what I did in a previous change is that I took out the fixed bias winding. It's just terminated nothing, so I don't let it just dangle anywhere to short. I soldered it to the tab and it's taken out of the picture. It's not doing anything. And how I'm doing the bias now, these are the cathode bias resistors and these are the cathode bypass capacitors, and that thing is here in series with the cathode bias resistor, and by adjusting the pot you can actually adjust the resistance of the cathode resistor, and hence fine tune the bias. So basically I have changed them to self bias. And by the way, I really warmly recommend all of you whose aim with your amplifier and with your stereo gear is not to have a very mechanical sound, but to take it towards a more natural sound. So if you think that you want a more natural sounding amplifier, then I extremely warmly suggest the change to self-bias, because in self-bias mode the tubes are, for one thing, much more healthy, because the resistor prevents them from running away, so that gives a level of protection, and they have a more natural sound like that. It will also decrease the high-end quality of the amplifier, so it won't sound so sharp, so shrill, so analytical. So if it's too analytical for you, go for self-bias. And if you have it in self-bias and you want more analytical sound, you want to make it sound more like a transistorized amplifier, change it to fixed bias. That will make it sound more like transistorized gear. And yeah, so that was one of my first mods I did. But companies are not doing this. They are all doing the fixed bias, because that gives, with the same voltage, with the same power transformer inside the unit, it will give you that much more plate voltage. Because in the self-bias mode there is voltage like 40 volts or so, 50 volts, 60 volts, depends on your amplifier and your supply voltage. That much volts, approximately 10% of the total voltage, is going to get lost through the self-biasing, and that translates to about 20 to 25% less output power. So basically the sound of vacuum tube push-pull amplifiers was really kind of like compromised by this numbers game, so that the companies wanted to sell more and more watts, more and more power. And if you advertise your amp as having, let's say, like 40 watts instead of 32 watts, then everyone went for the 40 watt amplifier. But in reality, like between 32 and 40, the actual power difference, that's not even going to make 1 dB difference between the two of them, which is inaudible, unnoticeable in real application. But the level, how much the sound quality degrades, that is very much noticeable. So my friend who has this amplifier, he's a classical musician, so yes, this goes against the notion that musicians don't care about sound quality. Yes, they truly do. and he was really happy with the change from fixed bias to cathode bias. What else? So what we have here is, when we look, this is the output transformer. So this is where the signal goes from the power tubes throughout, and that's the output terminals. And let's see, right close to it is the input section. So there's the RCA jack, and the input goes right there. So that's the input tube, and also one section of it is input, and the second section is the phase splitter. And now we have the 12BH7 tube, and that's the driver tube for the power tube. So each section drives one of the power tubes, so you see, and they are cap coupled. So that's actually pretty much stock. I have not changed anything in the driver, phase splitting circuitry, just like upgraded the capacitors to obligatos, and changed the resistors there. Those are, what are those? I think that might be the plate resistors, I don't know, something like that. But what else? So the big change that I did there was the introduction of an extra power supply section. So basically, even though we have the beefy double 5AR4 inputs, but they are still stressed by a capacitance, an input capacitance, which is 4 times higher than optimal. And also what it does, it doesn't only stretch the rectifiers, it also strain the rectifier, it strains the power transformer as well. But Mike, he kind of worked with it, so he made the power transformer oversized. But even with that, if you do not stress the power transformer and do not stress the rectifiers, the sound will be so much better. So there's a much better dynamics available, and also the extra filter section and makes this amp just super duper quiet. So the noise floor just drops below the floor. And what happens here is that I put a 56 microfarad input capacitor, which would be a little bit oversized if you had only one rectifier, but because you have two, each sees only 27 microfarads of capacitance, which is really in the sweet zone of the 5AR4 tubes. It makes it a really light duty. So basically, if you have US, NOS vacuum tubes, rectifiers in this amp, with this input capacitance, they will outlast your lifetime, these vacuum tubes, and probably your children's lifetime as well. So you can keep a single set of tubes in here for multiple generations when you are running it this way. So basically there's this little 56 microfarad 500 volts rated input capacitor, and that's a 63 ohm resistor. So there's a tiny resistor there feeding the big capacitors, which now became the second cap instead of the first. So that was the big change for the power supply. The taking off of the fixed bias was the big change for how the power tubes are being run. And I did another change here. So you see there's a pot in here, and this pot is basically, it's a 50 kilo ohm pot. Oh, I think it might be even bigger. Maybe it might be a half a mega ohm. It might be half a mega ohm. And what it does is that there I have a resistor here. I forgot what value, and that's in series with the pot. And what you can do is dial it one way, and then it will have the same amount of feedback as the Quicksilver normally is, and then you can turn the pot all the way over, and that will basically almost take out the feedback loop. So and then you can adjust, dial in the feedback to the amount you want. So now this amplifier has been an adjustable feedback amplifier. And you can notice that there's some speakers which are like current hungry. They like it if you engage the max feedback, but if you have like single driver speakers, they sound way better when you are taking out the feedback. So that's it. That's why I wanted to make this video, to have this documented before I rip out completely this section and replace it for the 807 tubes, which have a very different tube socket. They use a 5-pin tube socket. So this is how they look like. 5 pins instead of 8. Look, other unit already has them installed. Yay! So that's it. I think I don't have anything more to add here. That was my Quicksilver log of the day. Bye bye!